So for example review, this is page 3, part A. So it says, take the integral with respect to x. Yeah, you're trying to find the area. Find the area and take the integral with respect to x-axis. So what do we have here? We have 4x plus y squared, which is equal to 0. And the second guy is 2x plus 4. 2x plus 4. So when you're taking the integral, the very first step is to visualize the region and the boundaries that you have. So if you want to take a look at this here, you have a line, x-axis, y-axis, y equals to 2x plus 4. So this is your line. And -2. So this guy is behaving like this. This is your line. And this map here, y squared equals to plus minus square root of 4x. So if you want to graph this here, the graph looks like this. Okay, so let us take a look at the region that we have. The region that we're dealing with is this region here. And we are taking the integral with respect to x. We don't have any values for x, so what are we going to do first? We're going to set these two equal to each other and try to solve for x. So first, solve for x. Okay, so here you have 4x plus y squared equal to 0. But what is your y? Y is 2x plus 4. We're going to substitute this guy here. We get 4x plus 2x plus 4 squared equal to 0. So 4x plus 4x squared plus 16x plus 16 equal to 0. Very well. So here we have 4x squared plus 20x plus 16 equal to 0, or x squared plus 5x plus 4 is 0. So x plus 4 times x plus 1 is 0. So x is -1 and x is -4. So what's the meaning of that? It means that if I just want to take a look at this guy here, the region, this is -4 and this is -1. And let me just graph it the way that makes sense here. This guy is here. This is my line. Suppose this passes through here. This is my line. Y equals to 2x plus 4. And the graph that you have is passing through like this. Okay. So if you want to start taking the integral, it says with respect to x. Your x ranges between -4 to -1 to 0, and you have to divide and separate this region into 2 parts. Why is that? Because at the point of intersection between these 2 functions, between these two graphs. One part is the part on the left-hand side. You can see it right here. It's bounded by two y values. So one of the y values is this line, and the other y value is down here. But for the rest of it, on the right-hand side, if you forget about this left-hand side, on the right-hand side, you have the boundary y values by this map here. You cannot include the line because you get only two y values, upper bound, lower bound, or the difference between these two. So again, for this part, it's from top bounded by 2x plus 4, but down here, it's bounded by y equals to negative square root of 4x. For this part, the second part, on this side, a little bit of good symmetry, because this graph is symmetric, and you get the big picture. For this part, on this side, your y value on top is y equals to positive square root of 4x, and let's see, negative 4x. Negative down here inside the radical as well. And here, by the rest of the function, the negative part of the function, y equals to negative square root of negative 4x. So you have to divide up your integral into two pieces. One piece is negative 4 to negative 1, where these two intersect. So integral negative 4 to negative 1, bounded by these two y values, 2x plus 4, minus this function down here, negative square root of negative 4x, plus the rest of it, plus the rest of this object bounded between negative 1 and 0, dx, to negative 1 to 0. On top, it's bounded by square root of negative 4x, and down here, it's bounded by minus square root of negative 4x dx. There you go. So this is part A. It was for question 1. Now we're going to solve part A for question 2. A. The function is x plus 1, or the graph is x plus 1 equals to 2 times y minus 2 squared. This is the first map that you have, and the second map is just a line, x plus 6y is equal to 7. Well, so as usual, first we need to find the boundaries for x. You can graph this and take a look at the graph. You can use decimals or just try to graph this, no difference. So you have x plus 6y is equal to 7. Let us isolate y here and then substitute that back over there. Or we can just write x in terms of y and substitute that here. There's no difference. So here you have x plus 6y equals to 7. 6y is 7 minus x, or y is 7 divided by 6 minus x divided by 6. So substitute this guy into the first equation. You get x plus 1 equals to 2 times your y is 7 over 6 minus x over 6 minus 2 to the second power. So x plus 1 is equal to 2 times So let's do the subtraction between these two. -5/6 minus x/6 to the second power. Very well. Let's raise this guy to the second power. Construct a quadratic equation. X plus 1 equals to 2, 25/36. And here you have, this is going to be just positive, plus 2 times 5 times x divided by 36 plus x squared over 36. Let's simplify this as much as we can. X plus 1 is equal to, let's see. So if I take this denominator and multiply it by the other side, it makes it a little bit easier. So I'm going to multiply these two. 50 divided by 36 plus 20x divided by 36 plus x squared divided by 36 equals to x plus 1. So I'm going to multiply both sides by 36. 36x plus 36 is equal to 50. 20x plus x squared. So x squared, here you have -16x. And here you have plus 14 equal to 0.
Professor?
So let me check the calculations.
I have a question about the steps. Oh.
So this guy is x minus 7, x minus 1. Equal to 0, so x is 1 and x is 7. Okay. Now let us think about these functions. One of them is a function, the other one is just a mapping. So you need to isolate y on one side. Here you have 2 times y minus 2 squared equals to x plus 1, or y minus 2 squared is equal to x plus 1 divided by 2. Y minus 2 is plus minus square root of x plus 1 divided by 2. So y is 2 plus minus square root of x plus 1 divided by 2. And the other guy is x plus 6y equal to 7. You can use Desmos or any graphing device that you have and visualize this guy here. So one of them is just a line. This is your line, x plus 6y equals to 7. And the other guy, as you can see, here you have plus minus, so you have to consider the positive side and negative side as well. So if we try to graph it, I'm sure the graphing is very nice here. Okay. 7. That one over there. The intersection is going to be not this far, a little bit in the middle, because we have one at the point of intersection. So it's going to be something like this. So the area that you're looking for is this area here. Let me see. Just making sure it's visible to everybody. So this is the area that you're trying to find. Your x is bounded between 1 and 7. We don't have any problem with 1 and 7, but the upper function is your line. This is your line as the upper y value. And this is y equals to 7 minus x divided by 6. This is your y value from top, and Down here, it is the negative sign. It is y equals to 2 minus square root of x plus 1 divided by 2. Now you can just set up your integral. So your integral is going to be from 1 to 7, and the top function is 7 minus x divided by 6 minus the lower y, 2 minus. And this is inside the radical. Sure. 2 minus square root of x plus 1 divided by 2. Minus 2 minus square root of x plus 1 divided by 2 and dx. So on page 2, question 3. On page 2, question 3. We have the integral -1 to 0, x plus 1 to the third dx. So the very first method is to just write this in expanded form and then start taking the integral. The second method is use u sub. So you can say that, hey, u is equal to x plus 1, du is dx. So this guy can be written as the integral. uq du, which is a fourth, u to the fourth plus c. So since it's a definite integral and we can just convert this guy back into x plus 1, this is equal to a fourth x plus 1 to the fourth as x ranges between -1 to 0. So first we plug in 0, then we plug in -1, then we do the subtraction. This is a fourth. So if I plug in 0, I get 1 to the fourth minus. If I plug in -1, I get -1 plus 1, which is just 0, 0 to the fourth. So it is just. So question 2, page 5. Well, question 2 says, let's see, you have y equals to x squared minus 3x plus 2. And then you are rotating this guy and y equal to 0 about y-axis. And what is the volume? First, graph it. What's the graph like? Okay, here we have a quadratic function here, which is, if you just write it as factor form, it is the multiplication is 2, the sum is -3, so it's 1 and 2, and 1 and 2, this guy passes x-axis. So this is your quadratic function. And the other guy is y equals to 0, which is nothing but x-axis. So this is x squared minus 3x plus 2. And the other one is just x-axis, which is here, x-axis. So the region that you're taking and start rotating it about the y-axis is this region here, this little region. Note that the bottom function is x squared minus 3x plus 2. we are taking this and start rotating this about x-axis, right? So the sky is going to be just the same here, and then start the rotation. And this is the object that you get by rotating this. Okay, so V, or the volume, is equal to the square root of. So what's the circumference and what's the height? Times the height. So if you find these two, the rest is easy. And okay, circumference is just 2 pi times x. And what about the height? What is the height here? Is this function minus this function, or this function minus this function? What is this distance? The top function is 0. The height is 0 minus x squared minus 3x plus 2, which is negative x squared plus 3x minus 2 dx. Then you distribute x into parentheses, and then you're done. So here you have 1, 2, 2. We already calculated that. If you set it equal to 0, x is 2, x is 1. The boundary for your x, and the rest is just taking it into. Page 4, question 1. So here you are rotating R1. Question 1, page 4. We are rotating R1 about OC. OC. So let's take a look at R1. So this is my X, this is my Y. R1 is just this triangular shape here. This is my R1. And I'm rotating that about OC. What is OC? OC is this, okay, y-axis. This is OC. So we're taking this object and start rotating this about y-axis. Okay. And we want to know what the volume is. Do we have any other information? Yes, the intersection is 8. So it's going to be minus 8 on the other side. And the equation for this guy is, okay, x is equal to 4y. X is equal to 4y, and this is y, and this is our x. All else is given, nothing else is given. Very well. So to find the volume of rotation, so we are rotating this about y-axis. We can apply different methods. You can use the disk method, or you can use the shell method. So let us calculate the volume, the maximum volume. So maximum volume, the volume minus the minimum volume. So the maximum volume, the cross section of this object is pi r squared. So this is the integral of pi r squared minus the integral of the minimum volume pi r squared. So the maximum volume is related to this x equals to 8, and the minimum volume is related to x equals to 4y while you start rotating this. So here you have the integral of pi 8 squared, and here we have dy minus the integral of pi r squared. Your r is 4y squared dy. So you can calculate each of these separately and start calculating the volume of this object rotated around OC.